Hi students, I am Lakshmi Pallavi, Assistant Professor in Basic Sciences and Humanities, Mathematics Department from B.V. Raju Institute of Technology, Narsapur. I am teaching about the course Linear Algebra and Calculus, and in Linear Algebra and Calculus, today we will be studying about rank of a matrix using echelon form and normal form. So let us see today rank of a matrix using echelon form. So echelon form is also called as row matrix or a row form in which you can find the rank of a matrix. So in echelon form mostly we will be finding the rank of a matrix using the row operations, or with the help of rows we will be able to determine what is the rank of a matrix. In echelon form, the first condition which we apply, or what we have to do is, we have to, whenever you are given a square matrix or any matrix, we have to bring it into the echelon form. In order to bring it into the echelon form, we will be using elementary row operations. So in order to bring any matrix into echelon form, the first condition which it should satisfy is that 0 rows, if any, are there in the matrix. Those 0 rows should be placed at the end of the matrix or at the bottom of the matrix. 0 rows, if any, are present, those 0 rows should be present at the bottom of the matrix. That is the first condition. And the second condition is, every first element of every row should be 1. So that condition is an optional condition. And the third condition is that the zeros before the non-zero element, the number of zeros before the non-zero element should be strictly increasing as we proceed from the first row to the last row. So, what are the conditions we have? The first condition is that 0 rows should be present at the bottom of the matrix or at the end of the matrix. At the end of the matrix. And the second condition is that first non-zero entry in a row should be 1, and this is an optional condition. So if we don't have 1 also, it is okay. Then the third condition is, the number of zeros before the non-zero entry, the number of zeros before the non-zero entry strictly increases as we proceed from first row to the last row, or strictly increases with the row number. Strictly increases with the row number. That means from the first row to the last row, as we are proceeding, the number of zeros before the non-zero element should be strictly increasing. Then the number of non-zero rows is the rank of the matrix. Yeah, when all these three conditions are satisfied, then we say that the matrix is in echelon form and the number of non-zero rows will become the rank of the matrix. Now let us see with one example. So let us see the first problem. So finding the rank using echelon form. So let us the matrix be 2 1 3 5 4 2 1 3 8 4 7 13 8 4 minus 3 minus 1. So this is the given matrix. Now what we have to do is we have to reduce this matrix into echelon form. So here you can see in the first row before the non-zero element, that is the first non-zero element in the first row is the number 2. So before non-zero element there are no zeros. So as there are no zeros in the first row, in the second row you should have 1 0, in the third row you should have 2 zeros, and in the fourth row you should have 3 zeros. So the number of zeros should be constantly increasing, or they should be strictly increasing. Now let us make this 4 as 0 and 8 as 0 and 8 as 0, which are there in the first column, using the first row. So R2 implies R2 minus 2R1, R3 implies R3 minus 4R1, and R4 implies R4 minus 4R1. So what, see, because we have 4 here, 4 minus 4 is 0 and 8 minus 8 is 0 and 8 minus 8 is 0. So in order to make this, we are using these row operations. So when you apply the row operations, the first row is not changing because we are not applying any operations to the first row. So write the first row as it is. Now come to the second row. 4 minus 4, 0. Then it is 2 minus 2, 0. Then 1 minus 4, that is 1 minus 6, that is minus 5. Then 3 minus 10, that is minus 7. Then coming to the second row, it will be 0, 0, minus 5 and minus 7. And the last row is 0, 0, minus 15 and minus 21. So this is how we are getting after applying the elementary row operations. Now you see in the second row, before the non-zero element there are 2 zeros. That means in the third row before the non-zero element we should have 3 zeros, and in the fourth row we should have 4 zeros, as we are going with the echelon form. Now let us make the zeros in the third row and in the fourth row using second row. So R3 implies R3 minus R2, and R4 implies R4 minus 3 R2. So when we apply these operations, first row and second row are not changing because we are not applying any operations on them. So write the first row and second row as it is. Now come to the third row, R3 minus R2. So 0, 0, 0, 0. And coming to the last row, it is also 0, 0, 0, 0. Now we can say that this matrix is in echelon form. As you can see, the 0 rows are placed at the bottom of the matrix, and the number of zeros before the non-zero element are constantly increasing. Now, how many non-zero rows are there? There are 2 non-zero rows, hence the rank of the given matrix is 2. As there are 2 non-zero rows, we can say that the rank of the matrix is 2. Now let us take one more example and then find the rank of the given matrix. 1 2 3 0, 2 4 3 2, 3 2 1 3, 6 8 7 and 5. Now let us take this matrix. Okay. Now you can see the number of zeros before the non-zero element in the first row. There are no zeros before the non-zero element. See, 0 is present in the first row, but that 0 is placed after the non-zero element. We are only considering the zeros which are before the non-zero element. So, R2 implies R2 minus 2R1, and R3 implies R3 minus 3R1 and R4 implies R4 minus 6R1. So, we are using this element 1 to make all other elements in the first column as zeros. So, the first row will not change, it is 1, 2, 3, 0. Now, coming to the second row, it will be 0, then 4 minus 4, 0, then it is minus 3 and 2. Now, coming to the next operation, R3 minus 3 R1. So, it is 0, 2 minus 6 minus 4, and it is minus 8 and 3. Then coming to the R4 minus 6 R1, it is 0, minus 4, minus 11 and 5. So, this is how we get the operations. Now, you see, in the first row, before the non-zero element, there are no zeros. In the second row, before the non-zero element, there are 2 zeros. So, in the third row, we should have 3 zeros. So, let us make these two elements as zeros. Or otherwise, let us do one thing, we will interchange row 2 with row 3 so that the number of zeros will be constantly increasing. Now, let us interchange row 2 with row 3, then you will get 0, minus 4, minus 8, 3, 0, 0, minus 3, 2, 0, minus 4, minus 11, 5. Now, you can see in the first row, before the non-zero element, there are no zeros. In the second row, there is 1 0. In the third row, there is 2 zeros. So, in the fourth row, we should have 4 zeros. So, first let us make this minus 4 as 0, which is there in the fourth row. So, R4 implies R4 minus R2 using row 2. 1, 2, 3, 0. 0, minus 4, minus 8, 3, 0, 0, minus 3, 2, then it will become 0, 0, minus 11 plus 8. So, that is minus 3 and 2. Now, you can see in the first row before the non-zero element there are no zeros. In the second row before the non-zero element there is 1 0. In the third row before the non-zero element there are 2 zeros. So, in the fourth row before the non-zero element there should be 3 zeros. So, R4 implies R4 minus R3. R4 minus R3. So, first row is not changing, second row is also not changing, third row is also not changing. Now, it is 0, 0, 0, 0. Yeah. Then the 0 rows are placed at the bottom of the matrix and the number of zeros before the non-zero element are constantly increasing. So, we can say that this matrix is in echelon form and the number of non-zero rows are 3. Therefore, the rank of the matrix is 3. The rank of the matrix is 3. So, the rank of the matrix depends on the number of non-zero rows which are present in the matrix. Now, let us see one more example. Find K such that the rank of the matrix A is 2, where the matrix A is equal to 1, 1, minus 1, 1, 1, minus 1, K minus 1. Yeah, this is the matrix A. We have to find the value of K so that the rank of the matrix is 2. Okay. Now, first let us convert this into echelon form. So, when he is telling that rank of the matrix is true, that 2, that means there are only 2 non-zero rows present in the matrix. Yeah, because in the echelon form, the rank of the matrix is nothing but the number of non-zero rows present is called as rank of the matrix. So here, since he is already telling that the rank of the matrix is 2, which means that we should have only 2 non-zero rows. That means the third row is completely a 0 row. Now let us convert this into echelon form. R2 implies R2 minus R1 and R3 implies R3 minus 3 R1. So 1, 1, minus 1, 1. First row is not changing. So 0, minus 1, minus 1, minus 2. So it will become K plus 1, minus 1, minus 1, minus 2. So 0, 1 minus 3, minus 2. 0 minus 3 is plus 3. Then 1 minus 3, minus 2. Okay. Now, since we know that the number of zeros should be constantly increasing for a matrix to be in echelon form, so let us convert the third row into a 0 row, or this element which is there, minus 2 in the third row, let us make it as 0 using second row. R3 implies R3 minus R2. 1, 1, minus 1, 1, 0, minus 2, K plus 1, minus 2, it becomes 0, 0, yeah, then 3 minus K, minus 1, so 3 minus 1 is 2 minus K, minus 2 plus 2 is becoming 0. Yeah, since we know that since given rank of A is equal to 2, therefore, the number of non-zero rows also should be 2 and the third row should be a 0 row. Therefore, the third row should be a 0 row. The third row should be a 0 row. Hence, what we can say? 2 minus K equal to 0 or K equal to 2. K equal to 2. Understood, ma? How we have calculated the value of K when the rank is given. So, this is all about echelon form. Now, let us move on to normal form. Okay, let us take this example and then let us find the rank of a matrix using normal form. So, this is 2, 3, minus 1, minus 1, 1, minus 1, minus 2, minus 4, 3, 1, 3, minus 2, 6, 3, 0, minus 7. Now, we are trying to find the rank of this matrix using using normal form. In normal form, we are always trying to bring an identity matrix using the elementary row operations and column operations together. Now, let us try to make all the elements in the first column as zeros. R2 implies 2R2 minus R1. R3 implies 2R3 minus 3R1. R4 implies R4 minus 3R1. So, we are getting 2, 3, minus 1, minus 1, 0, minus 5, minus 3, minus 5, 0, minus 7, 9, minus 1, 0, minus 6, 3, minus 4. Okay. Now, let us use column operations and then make these 3, minus 1 and minus 1 as zeros. So, C2 implies 2C2 minus 3C1. C3 implies 2C3 plus C1. C4 implies 2C4 plus C1. This is how we apply the column operations and make all the elements in the first row as zeros except the element 2. So, it will become 2, 0, 0, 0. Yeah, this will become 0, minus 5, minus 7, minus 6. sorry, 0, 0, minus 10, minus 14, minus 12. 0, minus 6, 18, 6. 0, minus 10, minus 2, minus 8. Okay. Now, let us make the you can see in the second column and in the third column and in the fourth column, we can divide them with 2 and then write. So, let us divide them with 2. So, we can use for row operations also. C1 implies 1 by 2 C1. C1 implies 1 by 2 in C1. Now you can use row operations also. R2 implies R2 by 2. R3 implies R3 by 2 and R4 implies R4 by 2. Then we get 1 0 0 0. Here also all zeros. Then minus 5, minus 3, minus 5. Then minus 7, 9, minus 1, minus 6, 3, minus 4. Yeah, this is the matrix which we are getting. Now let us make minus 7 and minus 6 as zeros using the second row. So R3 implies 5 R3 minus 7 R2. R4 implies 5 R4 minus 6 R2. So you'll get 1 0 0 0. Here also all are zeros. So minus 5, minus 3, minus 5. Then it is 0 0, 66 and 30. Then it is 0 0, 33 and 10. This is what we will get when we apply these operations. Now we are always trying to bring a identity matrix. Now, so C2 implies minus 1 by 5 C2. C2 implies minus 1 by 5 C2 and C3 implies minus 1 by 3 C3 and C4 implies minus 1 by 5 C4. So that there are common elements, so let us divide so that the matrix will become simpler. So it is 1 0 0 0, 0 1 0 0, 0 1, yeah, 22, minus 22 and minus 11. Then it is 0 1, minus 6 and minus 2. Now let us try to bring the identity matrix using the column 2. Let us make other two elements as zeros. That is C3 implies C3 minus C2 and C4 implies C4 minus C2. 1 0 0 0, 0 1 0 0. So it is 0 0. Yeah. Minus 22 minus 11. It is 0 0, minus 6 and minus 2. Okay. Now let us divide these elements, let us change, let us make R4 as zeros. So R4 implies 2 R4 minus R3. So it is 1 0 0 0. 0 1 0 0, 0 0 minus 22 minus 6, it is 0 0 0 and this will be 0 0 0 minus 2. Okay. Now let us make this 22 as 1. So C3 implies minus 1 by 22 C3. C3 implies minus 1 by 22 C3. So, what are we getting when we do this? Yeah, it is 1 0 0 0, 0 1 0 0, 0 0, 0 0 1 minus 6. 0, 0, 0, 2. Now let us make this 2 as 0 using third row. Sorry, minus 6 as 0 using this column, which is third column. So C4 implies C4 plus 6 C3. It is 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 2. Now let us divide the column 4 with 2. It is 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. So this is a matrix I4. This is the identity matrix of order 4. Therefore, rank of A is 4. We have got an identity matrix of order 4. So, rank of A is 4. Now, let us see one more problem on the same lines. Let us find the rank of a matrix using normal form. Let us find rank of this matrix using normal form. So, in normal form always we are trying to bring a identity matrix. So, using the first row, let us make all other elements in the first column as zeros. So, R2 implies R2 minus 3 R1. R3 implies R3 minus 2 R1. R4 implies R4 minus 5 R1. R5 implies R5 minus R1. 1, 2, 1, 0. Then 0 minus 4 minus 2, 2. 0 minus 5. Yeah, this is the matrix which we get after applying these row operations. Now let us see, in the second row you can divide it with 2 and the fourth row also we can divide it with 2. So R2 implies minus 1 by 2 R2 and R3 implies minus 1 by 2 R3. So once we apply these operations, it is 1 2 1 0 0 2 1 minus 1 0 minus 5 0 5, then 0 2 1 minus 1 0 1 minus 2 minus 3. This is what we are getting. Now let us again interchange column 2 with column 3 so that in the second row, because the second row second element should be 1. So for that reason we are interchanging second column with the third column. So what are we getting? 1 1 0 1 minus 2 2 2 2 minus 5 2 1 0 minus 1 5 minus 1 minus 3. This is what we are getting. Now let us make the other elements using this. R4 implies R4 minus R2 and R5 implies R5 plus 2 R2. R5 plus 2 R2. So it will become 1 1 2 0 0 1 2 minus 1 0 0 minus 5 5, then 0 0, yeah, R4 minus R2 0 0 0 0 0 0, then it is 0 0, yeah, 1 plus 4, 5, then minus 3 plus 6, so minus 5, 0, 0, 5 and minus 5. Now let us make this 2 as let us take the last row and add it to the third row, so that last 2 rows will become 0. So R5 implies R5 plus R3. So it will become 1, 1, 2, 0, 0, 1, 2, minus 1, 0, 0, minus 5, 5, 0, 0, 0, 0, 0, 0, 0, 0. So the last 2 rows have become zeros. Now let us apply the column operations. C3 implies C3 minus 2 C2. C3 implies C3 minus 2 C2, and C4 implies C4 plus C2. Now when we apply these column operations, we are getting 1, 0, 0, 0, 0. Yeah. 1, 1, 0, 0, 0. Then this is C3 minus 2 C2. So it will become 2 minus 2, 0. Then 2 minus 2, 0. Then minus 5, 0, 0. Then C3 minus 2 C2. Then we have C4 plus C2, 0, 1, 5, 0, 0. Okay. Now let us apply for this. R3 implies 1 by 5 R3. So we will get 1, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 0, yeah, it is 1, 0, 0, and it is 0, 1, 1, sorry, it is minus 1, 0, 0. Now let us make this element Now let us make this element in the second row as in the first row second element, let us make it as 0. So 1, 1, 0, 0, 0, 1, 0, 1, 0, 0, minus 1, 1, 0, 0, minus 1, 1, 0, 0, 0, 0, and 0, 0, 0, 0. Okay. Now let us make them as zeros. C2 implies C2 minus C1, 0, 1, 0, 0, 0, 0, 0, minus 1, 0, 0, 0. Here also let us make one more operation. C4 implies, okay, afterwards we will do. So 0, 1, 1, 0, 0. Now let us make these two elements as zeros, which is, let us make the element which is there in C4 as 0. So C4 implies C4 minus C2. So it is 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, minus 1, 0, 0, 0, 0, 1, 0, 0. Now let us divide C3 with minus 1. So C3 will become 0, 0, 1, 0, 0. C4 is as it is 0, 0, 1, 0, 0. So let us make C4 also 0. C4 implies C4 minus C3. that is 1 0 0 0 0 0 1 0 0 0 0 0 1 0 0 0 0 0 0. So the last column has totally become 0. Now you can see it is an identity matrix of order 3. Therefore, rank of A is 3. Okay. Thank you, ma.
Like, share and subscribe. Hit the bell icon for more updates.